Hello, hello. Okay, let's start. Where do we start from? Okay. Let's start by updating to latest Zig for real. So git log. Where's my revert? Oh, I'm in the wrong branch. There we go. Revert. Now. Git revert. Oh, wait, it knows. Reapply. It knows when you revert it knows that you're reapplying. Um, we now know how to avoid um, deadlocks. That's it. Then I'm going to go into everything that has. Oh, there's no search in here. There's no. I guess I have to open a file and then do io.select. We have three places where we need to fix these things. There's two guys in here. Need a buffer. To any error void. That should be sufficient. What's the problem? Oh, come on, man. That should work, though. That should work. Oh, no, it's because it wants a union. I mean, understandably, that is not enough. Oh shit. Huh. Hi Lars, just a question. Is all your code base migrating to Codeberg? Not exactly, no. There is a Codeberg all your code base. I don't see a reason to, just have one. Let's have two. The recommendation would be to maybe not do without maybe. The recommendation is to not have duplicates, so we're not mirroring repos back and forth. At least for now. Probably also in the future though. And but if you want to add a new project to all your code base and you want to put it um on Codeberg, that's fine too. Like in case you don't want to touch GitHub. But if a repository is already on GitHub and you want to contribute that, um, no, no migration. Zig as a project is more principled than I am personally, and the way I see it is that there's no reason. Okay, even jokes aside, there's no good reason to move all your code base away from GitHub. A lot of people that contribute to it are still comfortable on GitHub. If they ever become not comfortable with GitHub, there's an alternative. All your code base on Codeberg, so they can survive. And yeah, I see no reason to force everybody to move unless we get to a point where there's a concrete reason, like Zig as a project was like having serious issues with CI on GitHub, but I believe so far all your code base is fine. Okay, so we fixed one select. uh Two more to go. Okay, so with this we should not have we should not hang anymore. I'm in master. We're tracking master, and we were falling behind a few versions, and now um I've updated to a new version. Let's see if we keep hanging. Test. Okay, well, I don't hear myself. That's fine. Leave. Close. Yeah, no more hanging. In here, also no more hanging. Perfect. So this all works. So GA VLAN source. Do you see? Is this an amend? No, this is not an amend. This is fix. This commit fixes hangs that were present in the previous commit. Also bumps up the minimum version to current master. Okay, with this, we should have we've done this. That was easy. Let's do some of these other nice things. I would be kind of curious to compute packet jitter. Because we don't have this information right now, and I think it would be nice to print it instead. So yeah, you know what? Let's move this above. Although the Opus one is probably not bad, but anyway, it's fine. So how is this stuff? How does it work? Well, um, if we look at Jitter buffer has a write packet function, which we call when writing a packet. We also have next packet. The next packet is not important, I think, for us. What we care about the most is write packet. Now, here's the problem. When you write a packet, who is it that knows when the packet was supposed to arrive? I think the answer is yeah. Who is it that knows? I guess okay, so it starts with you sending the first packet. That's for sure. Whenever we receive the first packet, that is when we're supposed to that's the t equals 0 for us. Then I guess we know that the next one has to come in 20 milliseconds from now. That's the exact thing that we know, because that's the packet size. So we know that the next one should arrive in 20 milliseconds. Also, you know what I'm gonna add in here? I'm gonna add another Opus thing in the middle. Enable back and try dread. I think it's dread. There's a couple Opus things that I want to try. So let's give ourselves we have packets. Then let's give ourselves some information about stats. Okay, so stats is gonna be first packet T. First packet. These are timings, I guess. Time first packet. First packet time. Start time. Start time. I don't know. IOTA timestamp. Then opinion on Mojo equals Rust plus Zig. What? I don't know. Mojo equals Rust plus Zig. I would argue that your reaction is kind of imbalanced. Inputs do not equate outputs. Yeah, careful. If that's your alchemic formula that you're trying to run, you're gonna lose an arm and a leg at the very minimum. I would say that Mojo is Rust, Zig, Swift, Python, Julia, Neem, all combined together at the very least. Zig like metaprogramming? Hmm. Are they open source now? They're not open source yet, aren't they? So start time. Then we do packet count. And then we do Chris says we'll make it open. Well, I'm looking forward to that date then. I don't know. Have you used Mojo for anything? Because I don't know. I've seen some interviews, I've heard the stories, but who's using Mojo to do what right now? So start time, packet count, uh, total jitter, I guess we can call it. Total jitter. Um, what do we measure jitter in? Do we measure it in milliseconds? I think it's fine. Keep it integer in milliseconds. Is there a reason to do any different? No. Yeah, folks. Bento ML. Okay. Well, the point, I guess my point is this: if I have to make one serious point about Mojo, is that um, it ultimately doesn't matter much, at least to me, what it inherits or not from Zig or Rust or whatever, because um, like the use cases that you're presenting, like the users that you're presenting, and the use cases that it seems that they care about the most, it's not general purpose programming. It's a machine learning thing, right? Or rather, maybe it's not, but that's what's being used for. So, my suspicion is that for the foreseeable future, and maybe that will be for the full lifetime of Mojo. Maybe it will be an interesting option if you're doing machine learning. But if you're making a general application, like you're making a Discord alternative, um, I'm not sure it has anything particularly interesting in that case. And in a sense, you know, it will have lost the good things that Rust and Zig have, respectively, for general purpose programming. So I don't know if you're doing AI, whether you have a borrow checker or not, does it really make all that difference? I'm not sure. So um I don't know what the situation is for Mojo with regards to general purpose programming, and the fact that there is no push in that sense. While there is, well, the fact that it doesn't have penetration in that sense, but it does have penetration when it comes market penetration when it comes to AI, then makes me think that that's its destiny, maybe. So I don't know. Here's a funny thing: we don't have IO in here. We don't have IO, but we would like to be able to call now. At the same time, we would like to be able to call now like kind of fast, not kind of slow. So I guess write packet should give us an IO. I don't know. Let's assume that we get an IO. So total jitter ms is IO clock dot awake dot now duration 2. I guess it's kind of different, right? It's jb dot starts dot start time dot duration 2 now 2 milliseconds. So we increase the packet count, we increase this. I'm wrong. It's not start time. Okay, so here's the question. Wait, do we use the start time or do we use the last packet? We do not use the last packet because we're basically trying to test this against a um we are trying to test this against a like absolute clock. So in a sense, what we want is to take the original time, add to it 20 milliseconds times the sequence number that we're at, -1. And that's when this packet should have arrived. Chris made LLVM and MLIR. Yeah. So total time jitter ms is start time dot add duration from milliseconds 20 times sequence. Sequence starts at 1, so we do -1. So add duration from milliseconds 20 times sequence -1. Um, and then we do that time duration to the current time, milliseconds. Jesus, oh, this holy shit, we are like making a long thing. Can we do this? Yeah. Okay, add duration this. And then we do this. If the delta is inferior, we don't. So if, like, for example, if this gives us a negative number, this returns is signed. Duration also, I would expect to be able to represent signed stuff. Yeah, it can, because this is going to be all signed numbers. So negative delta, we don't add it. So if delta greater than 0, we add delta. So there you go. If it's a negative, it counts as delta equals 0. Now here's the problem. Sometimes there's going to be a restart. So there's going to be a restart. So if you go in here and the restart is different than our expected restart, we need to do something else. Well, first of all, let's add a print log.debug. Packet jitter. These many MSs. Then this is if gb.expected next sequence is current restart. What is it? If there's a new restart, then oh, when do we update current restart? Oh, you know what? I think these are numbers that it's on the reader side. These are numbers that we play with on the reader side. Oof. That is problematic from a concurrency perspective. For now, though, let's leave it at that. In the else case, so ideally in the else case, what we want to do is take the total jitter, average it out, I guess divided by the number of samples, by the number of packets. So let me think about it for a second. Let's say that we have 100 packets and one is 10 millisecond late. I guess we don't really want to average the jitter out. I think we kind of want to keep the worst. Let me think about it for a second. But no, well, yeah, no, that's kind of what we want. We want the worst. There's no reason to keep a track. Like we just want a worst jitter, like a max jitter MS. What is the most late that a packet has been? That's how big we kind of want the jitter buffer to be. Yeah. Although, almost not exactly. We don't just want the max. We kind of want, because one packet could be turbo late and it's just one. So it would be better to consider the one lost and instead, I guess you kind of want the second worst. That's it's an approximation. No, you want a better statistical estimator, but um, second worst could actually be a starting point. So if delta greater than jb.max jitter ms. Oh, you know what? We actually don't need to observe restart. Our restart. I think we can observe sequence. If the sequence start is at 1, then it's a reset. It's not perfect. It's kind of good enough. Yeah, so that way we don't look at current restart, which is problematic. You know what? I think we should do this. Okay. Otherwise, we write down the maximum jitter. Is this it? I mean, yes. Because in other cases, the jitter will not be a problem. Well, let's say that the first one is 20 milliseconds late, and the next one is 10 milliseconds late. Then you do want a jitter buffer that is a little bit bigger than 20 milliseconds. Max is actually not enough. We could do 2 times as much as max. There must be a better formula. There definitely is a better formula. Maybe it's max jitter plus the average jitter. I don't know. Mm, no, what you want is a measure that has to keep into account. Like you don't really want the max jitter, you want the max deficit. What you want, yeah, you want the max deficit. The max deficit is um the max deficit is we start, everything is perfectly fine. Then one packet is behind 5 milliseconds. So it arrives 5 milliseconds late. Let's talk about maybe in units of 20 milliseconds because it's easier to reason about. So you start, everything is fine. One packet arrived 20 milliseconds late. So you kind of go in deficit by 1. You can go deficit by 1. Yeah, you know what? I think this is not a competition that we do here at all. And I don't think it has much to do with this. I mean, while this print might be good to keep around because it might be useful, this is not what should drive the decision making. The question is actually so much simpler. The question is, what was the worst deficit that we were in the last before the last restart? That's how much you want to keep in your buffer. And if or rather, that's what you want to make sure to have in your buffer plus 1. So if, for example, we start, so currently our setting is that we have 8 packets in the buffer. Because of jitter, the worst deficit is that we go down from 8 to 6, then we could have very well, instead of having chosen 8, we could have chosen 3. And with 3, we would have gone from 3 packets to 1, and it would have worked. So, um, that is the biggest dip. So you want to keep track of the biggest dip. There's only one caveat. When silence arrives, there's going to be a dip all the way to 0. So the dip all the way to 0 does not count. So you can't just keep track of max dip. Also, hello, Penguin. I don't remember if I greeted you. Okay, this is really cute. I don't know. I'm tempted to keep start time just for be able to print this, just for being able to print this. Yeah, just for this. Oh, I could write down. Okay, let's do it like this. So, okay, let me undo. I will do this, and we have this restart. There we go. Okay, so this is cute, but let's do the reasoning. The reasoning happens in next packet. Where is it? In here. Next packet begin. So this is where we recognize that the sequence has changed. The restart has changed. So yeah, if the restart is greater than current restart, here we're switching to buffering again. We're switching the buffer to starting mode, which is the buffering phase. And I think in here is where we want to say, okay, do we have stats? Fuck, no, we don't. The problem is that in here we don't have stats for timings. We just do not have stats. God damn it. Here we do not have stats for timing for the last thing because we were pulling at a steady rate. We had no knowledge of when the packet arrived. In theory, we could mark each packet with its arrival time so that down here we can do the computation. We can delay the computation. But at this point, I think then I would really do the computation in here. No, what am I saying? What the fuck am I saying? We don't know that, we don't care. Wait a second. We don't know, and we don't care. The only question that we care about is how low did we dip? So the question is, after starting, what was the length of messages in our buffer? How many messages did we have in our buffer? So, So what we want to keep around is last LAN. Then we look at current LAN, and we look at if we went down from last LAN, and we write down the delta. And then, as long as we keep going down, we keep counting down. But then we only commit that count once we go up again. I think it's like this. Is it Java? No, this is not Java. Yeah, so here there should be some decision making, which we currently don't know how to make. But we can say the buffer lane is slices.len minus index. Okay, then once we found a packet to return, oh, what if we should be playing silence? Then what? Well, silence is a lost packet. That doesn't. That is a lost packet, and a lost packet doesn't really count much towards this decision making. So whether it's this or this, it doesn't really matter, I guess. So here we say um, if current len is greater than what if we're stable? We don't do anything. If we go up, we commit. If we go down, we wait for the next one. If we're the same, guess we stay where we are. Oh shit, access denied. I made changes that now uh yeah. Okay, we were saying um GB max deficit, stack count minus current len. So like I 8 minus 4. Let's say that we are at 4. Then that would be the max deficit. Um Actually, it is currently in last buffer length. So this is last stock count minus GB dot last buffer length, not the current count. Then else if I think we do nothing. Or you know what? We can do it like this. Hello, Marky. Okay, so look at this. Current length is lower than last buffer length. And we just want to take GB dot last buffer length equals current length. Why did I think that I needed a variable for the current length? Apparently, it's not needed. So we sample the current length. As long as the current length keeps decreasing, we write it down. When it increases again, we take the last lowest value and we put it in max deficit. Yeah. Okay, I guess we can add a print also for this. Here on the start, we can also do this. So with this, we track what the max deficit was. And right now we're not using it for decision making. So we're not using any of this stuff for decision making, but I don't know. Let's see what it looks like once we get to a compiling state, I guess. Memory expected for arguments found 3. Oh, right, because it now needs to give us IO. You have IO? You know what? This is a problem because we're doing length minus index. Well, I guess the fact that we entered in here means that length is at least 1. So I guess never mind. Disconnected sleeping. Where's my root server? I guess I killed it, maybe. Hmm. Okay, we need an echo server because we need to receive packets. Uh-oh. Okay, there's a few things here that don't work. Apparently I'm not sending any microphone data. I guess the question is, did I fuck up the test? 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 I don't seem to have fucked up the audio part, so I don't know why this is like this. Okay, let's try to... Oh shit. I did not mean to do that. Wow. Okay, let's try to do it less weird. Non-echo server, but 2 clients. There we go. But, oh no. Oh no. Oh no. Oh no. What have I broken this time, man? So, we don't seem to be Sending audio, sending the run host media sender has started. So that has started, but hello, crypto code. Some other stuff doesn't work. We did start the engine. Okay, just to be sure. Let's use the webcam. That works. We don't seem to be really recording. How have I broken this now? Oh man, I've broken this. I just don't know how. Have I connected the microphone to the sync node? Main mixer node? No. Capture mixer node. Connects input node to mixer node. That's fine. That is engine start. Yes. Do we do this? Capture mixer node. Capture sync node. Test main mixer. Capture mixer node to capture sync node. Oh. Are we getting null for user data? Well, we can see that the callback is not being called. Why? So the engine did start, and we did start these threads. Oh, I get it. 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 Yeah. I just can't help myself. You know what? It's just that I love it so much. This is the problem. God, I hate this API. This is the problem. God, I fucking hate this API. There we go. I fucking hate this API. Okay, so with this we should be able to do playback. Mm, do-do-do-do. Okay, this package jitter is max deficit was 5. Okay. Interestingly, with this jitter, we're mostly negative. Wow. Okay, let me write down that there's a restart also in the side where we do stats. Man, the network code is so easy, so simple, so predictable, so masterable. Okay. So let me explain these numbers here. This number is gigantic. This is like a lot of milliseconds. This is okay. So this is, I think this is not being initialized correctly on first round. So more or less. So this is definitely too much. Either that or is what the fuck? Like this is 1 second. Are we 5,800 seconds late? I don't think so. I don't know why it's like this, but fine. In any case, after we restart, everything goes normal. We're mostly negative by this much. I think I think my math is slightly wrong. I think that -1 this should be -2. I think because we cannot be constantly -20 something. We should be at around. We should be hovering at 0 at around 0, give or take. Test. Yeah, there we go. Or this is still weird. Why? Why this much? Why this much? I don't know. I don't know. I really don't know. Anyway, yeah, this is weird. Why is it still -20 milliseconds? Why? Why? Time sequence -2. Sorry. Why is the like? Why was this change? Why has this change not caused any difference in the counting though? Hmm. Yeah, it's like it's -20, 12, 20. Why does this make no difference? Kind of weird. So this should bring us more negative in theory. In theory, no. Same fucking numbers. Okay, how is this possible? Oh my god! Wait. Is this am I doing math dumb? I think I'm doing math dumb. This is a math dumb moment. Hello, CCPRN. There we go. Yep. Yep. And -2 is the okay. So my -1. So I didn't get the math wrong. Like I mean, I wrote the formula wrong, but my intuition was correct. You just want to do -1, and yeah, that's my local jitter. Probably the majority of this jitter is caused by uh after restart max deficit was 8. Holy shit. Um this is fine. Like this is mostly caused I think by local sleeps. Like this could be made tighter if I wanted to, but it's fine like this. After restart max deficit was 6. That's a lot. Now after restart max deficit was 1. Yeah. Now, yeah. Okay, this is good. Huh. 6. Okay, the fact that this says 6, this is a little bit too much. The deficit should not be 6. What? What? 6 is very aggressive. In any case, this seems reasonable, and I'm gonna try with my remote server. So give me a sec. I'm gonna turn on the remote server. Let's try. Okay, I have a remote server running. Okay. Oh, wait. There's a problem. The remote server is not Echo. The remote server is not an Echo server. We need to upload an Echo server build. Um, so one sec. Building an Echo server. Oh well, you can watch. It's taking a while to build. It's a release build with a new Zig, so it's building everything from scratch. Okay. SCP moment. There we go. Failure. Did SCP fail because I was running the server? SCP fails if you're using the file. Wait, what? It's what? Is this Windows? What's going on? In any case, I anonymized the upload, so it should be fine. This should be an echo server. It doesn't say that it is an echo server. I think echo servers should tell you that it's an echo server. Let's see if it is echo. Test. Yeah. Okay. Let's see. Let's see how it is talking with myself. Don't worry, you're gonna hear myself low. Doesn't matter. Test. Also, you know what? Settings. Actually, no, not these settings. These settings, we're gonna change our microphone to oh shit. No. This. And then this. Okay. Okay. The engine seems to have survived. That is awesome. I did not expect this whole thing to survive. So 1 of 9. After the start max deficit was 7, 8, 7. Test. 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 A. B. C. D. E. F. So these numbers seem a little bit sad. I was hoping for better numbers. So unless there's a flaw in my math, there could be. It could very well be that so I know that this whole solution is it's slightly simplistic. But on top of that, there could be some extra simplisticness that I'm not accounting for. But it seems a little bit sad to me that we very often it seems that we are they were late by a lot. Like a packet arrives 100 milliseconds later. Like this packet that has arrived 100 milliseconds later, if we didn't have or in general, max deficit was 5. I guess the problem is that these numbers, they don't get computed super well. I think I get it. Like the first packet will have some jitter inside of it. And so essentially, once you look at the whole series, you should actually be able to compensate. I guess what you should do is take every negative jitter and kind of bump up all the numbers so that none is negative, and that's going to be your actual series, I think. But in any case, these numbers for the packet jitter, the way they get computed, not the best way. Fine. But separate from that, there's the max deficit, and boy, do we go down with the max deficit very often. So 1, 1, like plenty of times it's 1, and that's fine. But then it goes to 6, 5, and 4. That is a lot. Like 6, 5, and 4 is a lot. Let's try again with another word. Another word. Test. Max deficit was 5. Expected 14. Found 11. Restart equals 9959. No. Excuse me, are we so high already? Test. Man, I'm not printing restarts, but just a second. Oh my god, I'm flipping around somewhere. Packet sequence and restart numbers. Yeah, you know what? That it maybe when I do the print, please God tell me that somehow I fucked up the print and I didn't fuck up anything else. That print is diabolical. That's not how it should be. Where is it? It's in here. Okay, it prints, wait, expected, and then it prints the next sequence, and then this guy prints the next meta. Okay. So you read expected sequence 20, found sequence 16. Expected sequence 20, found sequence 18. Okay, so these are like packets that arrive out of order for whatever reason. Okay. Okay. So this is, by the way, these are numbers that come from a super cheap Hetzner server. Maybe if you buy a less cheap Hetzner server, you get better numbers. Whew. Okay, so what did we learn from this? I think what we learned is that 8 times 20 milliseconds, so 160 milliseconds of delay might not be enough. Depending on the server characteristics, like even, okay, again, this is not the best server ever. This is not a deluxe experience that we're having right now, for sure. Not a deluxe experience. But in this case, the number might need to go up from 8. It might need to go up from 8. Hmm. So that means that maybe we need 32. We need buffers with 32 slots. And we need this to... And we need this to... we need this number to... we need to allow this number to grow bigger. Up to, I don't know, something like 200 milliseconds. Like we need an upper limit before at some point becomes in like... in any case, at some point, communication is just breaking down, and there's nothing you should be attempting. But interesting, truly interesting, truly interesting. Test, 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 test. 5, 1. You see, in many cases, we do super well and everything arrives super fast, and the max deficit was only 1. And in fact, if we look at this, the delay of these packets, this one is 92 milliseconds late. What the fuck? Then there's a restart. Hmm. I think this 92 might be an artifact. I think that these are the reads that you can kind of trust, and you can see that it dips all the way down to 23, 20. Like the worst is 20. It's a matter of runs, right? So the worst is 23 plus 7. So the worst was 30 milliseconds, which is more or less going down one packet. Let's see here instead. This was really weird. This was really weird. The first packet arrived really late. And then after that, all the jitters look very negative because the first one was super late. Like the first one had 70, more or less 70 milliseconds of delay, essentially. And the other ones kept arriving at a faster rate than that. Hmm. Yeah, so this whole read got twisted. And and then it went from everything super early to everything super late. But then max deficit was 1. And that kind of surprises me. Oh, you know what? Actually, no, never mind. So these arrives late. Oh, I see how you read this. Wait. The way you read this is that you read this text after reset deficit. This text applies from here until restart. Then this applies from here until restart. Wait, but then what does this? When does this apply? So what about these reads? What are they? This is what we're buffering essentially. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It kind of is maybe. I don't know. Oh man, look at these guys. Like for example, this is very good. Test, test, test. Huh. Test, test, test. Okay. So we have some information about packet jitter. Hmm. Um. Which clock are you using for this? I'm using the awake clock. So I'm using a monotonic clock, not real time. But I don't think that makes any difference. I can switch. I can show you. But that doesn't make any difference. The problem is that I'm basing. So the way I'm doing it is that um, when I receive the first packet, so there are two things to keep in mind. The first one is that out being in a call is a series of like sequences. Every time you mute yourself, there's a form of restart happening. So because there's no data being sent while you're muted. So any, for example, accumulated latency, it's kind of reset because you're just muted. So even if in any case, there's resets. Then every time we start, so after a if when you start talking after a silence, when we receive the first packet, we consider it the start time of these of the um, of the following sequence. Hello, Temporus. And then what we do is that to compute the jitter, we say, okay, given that start time, and given that we're currently at sequence number, um, there's a sequence number for every packet, and we know that every packet should arrive every 20 milliseconds, then we take the original time, we add 20 milliseconds times the number of packets, and then we look at the duration, like we look at the difference between that time and IO clock now. And I'm using awake. So I could change this to real. And although I'm going to change it back to awake after the test. But the problem, like the reason why I'm getting reads that are like somewhat indicative but not perfect is mainly because the first packet has a jitter. And I use that as a baseline, but that packet has a jitter of its own. And so I never tried to figure out what the jitter of that packet was. Test, 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 test. How would out of order UDP packets show up in these measurements? Good question. They would show up as um, just being a packet that arrives really late. So, for example, this guy might be a packet that arrives out of order. We could try to show this. Um, oh, that's why the first read is really weird. Because if restart is different than JB starts restart, but the problem is that restart starts at 0. I think I should have restart start at 1. Do we do that in network? Sequence 0, restart 0, sequence plus 1. Let's have restart start at 1. I think that's a good property. Okay, so we have restart start at 1. Then here we do I guess we can say late. Okay, let's see if we are seeing this. So we were seeing, by the way, there's also another thing that shows us when where packets are arriving out of order. But the thing that we were seeing there, only we see it only once we get to the consuming end, not to the receiving end. What? Wait, we're missing this. I guess we could do this. Would this make sense? No, I don't think this would make sense. I mean, I'm gonna try it, but I don't think this makes sense. Test. 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 Okay. I expected worse. Test. Test. Well, okay. So this, I don't know how robust of a method that is, but at least with the current network that is not too horrible, it does kind of show. Test. So most packets arrive in order. Occasionally, some do arrive out of order. So here you can see these guys are out of order. I'm guessing these two guys flipped around, maybe. Maybe these guys were flipped around. I guess we can do this. We can print the sequence number. Test. Yeah. Yup. Test, test, test. A, B, C, D, E, F, G. Yeah, here 10 and 9 have swapped over. So here you can see that packet 0, sorry, I should say packet 1. Packets like sequence numbers restart every time you shut up. And they started 1 when after they restart. So packet 1 has arrived. We don't have anything to compare it against, so we don't know. The next packet arrives 4 milliseconds earlier. That means that this packet up here probably had at least 4 milliseconds of jitter in it. Because the idea is this: packets cannot arrive late. Cannot arrive early. It is impossible for a packet to arrive early. the only thing that could happen is that we overestimated the start time. So for this to be -4, it means that the original packet had 4 milliseconds of jitter in it, at least. This one down here is 5 milliseconds early. So that means that this one in the beginning had 5 milliseconds of jitter. This one had 1 millisecond of jitter. These ones have 5, 12, 7, 13, 7, 0, and then 85 milliseconds of jitter. So those are the real numbers, most probably. The problem is that we have to start with a baseline, and we would have to do a bunch of adjustments on the fly. Although we could basically every time we find a negative number, we move forward the initial estimate. Actually, why not? Let's do it. Like, why not? Why not? Man, I hate how I'm trying to make this informative, not too convoluted. But so how do we show the plus? Maybe we don't show the plus. In any case, here we do yeah. So that in theory should have, maybe, I don't know. uh, uh, um, okay. You know what? Not so sure anymore. uh, so why were we going? Why was this so problematic? We take start time and we replace it with start time plus adjustment milliseconds. And that's the new start time. Yeah, so since we're not printing adjustment, we can even do this. I mean, nothing should have changed. So, yeah. Blah, 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 blah. Crashing software with my voice. Delightful. So what am I missing? Am I somehow like not supposed to subtract this? Like what's going on? No, so oh no, that is correct. What we're saying is that the real um arrival time is earlier than what we estimated. So yeah, we should subtract. Okay, that makes sense. So with this, we update our estimate as we go forward. Blah 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 blah. What do you think of my proposal to somehow distinguish arena allocator from other allocators so that if you want an allocator that fully supports the allocation of individual elements, you won't be able to pass an arena allocator as one. But if you don't care about the allocation, you can just use real allocator interface and pass arena in other allocator. Uh, you say it's a proposal. What kind? You're suggesting to change types in the standard library. Well, here's one problem. It is very convenient sometimes to pass an arena allocator to a function that wants a GPA because the function is designed to do a GPA to be used with a GPA for general purpose use cases. But in your specific use case, you have a surrounding frame around the whole thing. And so in your case, it's convenient to use an arena allocator so that you can free everything at once. So you don't even call destroy, you just straight up reset the arena. So with your proposal, a function, for example, you wouldn't be able to put inside of an arena a hash map anymore because the hash map would request a general purpose allocator and you wouldn't be able to supply an arena allocator anymore. If you want a recommendation, um, if you do it the opposite way, if you have a function that wants an arena allocator, there are two options. One is you literally accept an arena allocator, or you accept a GPA and then you build an arena allocator on top of the GPA that you've been given, or you accept an allocator, but you name the variable arena to suggest to the user that you're going to take that allocator and use it as an arena. So just so that we're on the same page, if you're making a function that wants an allocator, don't do this. Don't do allocator. No, do this. Do GPA if you're accepting an allocator that you plan to use as a general purpose allocator, or accept arena if you plan to use it as an arena in your function. That way you communicate intent. And obviously that should also be part of the doc comment of your public API. And then you let the consumer decide if they, if you ask an arena and then they give a GPA, that's a problem. It's their fault. If you ask a GPA and they give you an arena, that's fine. There's no downside. Okay, so what were we saying here? Right, we were looking at these numbers. Wait a second, what happened here? Late. 76 milliseconds. So we went from 0 to 76 milliseconds of jitter. Huh. Also, you know what? I think that maybe it's okay. Okay, test. 6, 7, 4, 5, 0, 1, 5, 5. Okay, let's debug a little bit those other counters. Let's add some printing just so that we can see these numbers change over time. Okay, let's see how we're doing. Test. Okay, let's see. We started. Current len is 10. 10, 10, 10, 10, 10. Then 9. So biggest dip, 1. Or more precisely, from 10 to 9 to 10, that means the 9 is the biggest dip that we've seen. And then we go all the way down to 0. So this should say 1. Now, when I'm unmute myself, this should say 1. Test. Restart max deficit was 8. Who wrote this code? Who's so bad at math? God damn it. That's me. Can't even blame anybody else. How would you end up with this fucking number? Why, man? Start count minus last buffer len. Yeah, actually, to be fair, the fact that here we got to the fact that here we got above 8, we shouldn't even be returning 9. We should returning 0. Okay, I'm gonna look at this. I'm gonna get some tea. Okay, let's see. Join. Okay, let's see what happened here. Current len 7, current line 6, current line 7, current line 7, 7, 7, 6, 6, 5, 4, 3, 2, 1, 0. Okay, so this should return 1. Also, new max deficit equals 8. How does this return 8? New max deficit is 8. Current line is 7. Oh, because this was 0. The fact that we start this as 0 is the problem. Yeah, last buffer len should be on a restart. Last buffer len should be put at what is it now? Start count. Actually, it should default to start count. Okay, that explains the wacky numbers. And now I'm making a custom build step for caching. Test. Okay, let's see what happened here. Current line 7, 6, from 6 to 5, then back to 7. Max deficit 3. Correct, because the biggest dip was from 8, our water level. Our the default number of packets that we're buffering, because right now the number is static. We went from that. We went to what is it? Yeah, to 5, which is 3 below 8. Okay. Then we went from 7, 6, 7, still 3. This is another dip. 7, 6, and then 7. Another dip, but this dip is smaller than the previous one, so we stay at 3. Another dip, 6, 6, 7. Let's see. 7, 6, 5, 4, 3, 2. Then 2 again. Doesn't matter, doesn't count. Then 5, which puts max deficit at 6. Okay, so this surprises me. This surprises me, but I guess that's what happened. Okay, I'm going to try another run. So in any case, max deficit is 6. So that's fine. Let's do another run. Test. Okay, let's see. Restart. Max deficit was 6. 7, 7, 8. Yeah. 1. 7, 8. 7, 7, 8. 1. 1. Okay, so in this case, max deficit was 1. Let's try again. Blah. Max deficit was 1. Try again. 8, 7, 8, 1. 8, 7, 8, 1. Yeah, okay, there we go. Oof, we solved it. Okay, we solved the wonky math. So that means that we can now run this in a better way. Test. 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 A, B, C, D, E, F, G, H, J, K, L. I think I'm missing I. 1, 2, 3, 4, 5. What about max deficit being 0? Yeah, so with max deficit being 0, this is interesting. When max deficit is 0, it means that the first packet had so much jitter inside of itself that everything else ended up arriving early in comparison, and so we never went down. Um, huh. So yeah, I don't know what the solution is for this stuff. Arena GPA. But I mean, you know that you can accept an arena, a pointer to an actual arena. Like if you really want an arena, then don't make your own custom type. Do this. Do function foo, and then arena is literally a pointer to sd heap dot arena allocator. You can do that if you really want. Like if you really want your user to give you an arena, ask for an arena. Be aware though of one thing. You need to clarify if you accept an arena implementation, then you must clarify in the interface from no ops from arena. But the fact that there are no ops means that they're essentially free. Like you shouldn't worry about frees that run on an arena locator that become an ops. That's fine. Um, but anyway, if you want to do this, and then be careful only on one thing. If you accept an arena implementation, you need to clarify with the caller if you're going to reset the arena or not, because they could be giving you a fresh new arena, and then you use it, and then maybe you reset it internally multiple times depending on your needs. That's fine. But if they give you an arena that already has data in it, then if you reset it, that might be a problem because they were counting on that data being alive after calling your function. So this is more powerful, but also more dangerous because you could be resetting this arena, or you or whoever else you give a pointer to this arena yourself. So be careful because it's a more delicate arrangement, but you can totally do it. If you want something more safe, accept just a normal allocator, call it arena, write in the comment where your usage pattern is going to be. If your users use your functions without reading the comments, they don't deserve your protection. Okay. Do. So what have we learned here? What has this taught us? Uh-oh. Oh, we're back. What did we learn? Hmm. Test. 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 Blah. Okay, so we have an estimation of how much we dipped. I guess the question is how close to the danger do you want to flirt? Because looking at this connection right now, right? Looking at these tests right now that I'm doing in real time, that number is changing a lot. So when in a segment you only dip by one packet, do you want to go down to one? I don't think you want to go down to one because it's it's problematic, right? A moment ago you needed 5. Another thing that we're not uh, keeping count of is sometimes if something is late enough, I think we should consider it dropped. By the way, you know what? We could do this eagerly. We could do this eagerly. We could say, look, if your packet arrives later than, let's say that our buffer is, I don't know, 4 packets. If your packet arrives more than 80 milliseconds late, what even is the point? Just drop it. We could do that. Now, what would be the downside of this? That if the packet was missing, we would be dipping more? We would be dipping more, maybe, but I don't know. So we have something to measure this information. That's good to have. Other than that, I don't know. So we are computing packet jitter. That's good, I guess. Better than nothing. Uh, let's take a look at enabling forward error correction in Opus. And there's also Dread. Yeah, we can test these guys with the debug functions that we already have. So if I go to Opus, when we create an encoder, decoder, decode float FEC. I mean, wait, why is there a FEC option on the decoder side and not on the encoder side? Shouldn't you like... No. I see how it is. I think I understand how it works. Forward error correction means that the decoder will buffer one packet. It will give you the packet, the audio data for the previous packet. And the hope is that if the previous packet was missing, but we have a new one, then we use the new one to produce something that is not silence in the middle. So I believe the forward error correction protects you from one packet being lost. Yeah, let's turn it on. Like, it's literally just this. Okay, I now understand how this thing works. Maybe. Interestingly, this is not something that the server cares at all about, so I'm able to make this change here now. Here's what I'm gonna do. I'm going to mute the music, and we're gonna listen more closely to what we're gonna listen more closely to what we get from the network. Test.
Test.
Test. I don't think we're hearing back. Is this the remote one? Yeah, this is the remote one. Uh-oh. Maybe it turns out that enabling forward error correction is more complicated. Test. Nope. The code missing. What does it? Oh, the code missing also has... Wait a second. So this one also needs to be turned to true. And down here as well. Maybe. I mean, at least this case we have all the settings aligned. Oh, I pressed the button too early. Test. Nope. Is this setting causing it, or is it something else? Let me turn it off. Turns out that I did not understand how to do FEC. Test. Yeah. Fuck. uh. Test. Oh shit. This caused way more panic than I was expecting. Leave. Join? No. We're toast. Okay, this thing has corrupted everything. Holy shit. Okay. Test. Let's try one packet. Wow. Oh, there we go. Dropping media packet 0, run host media receiver exited. So basically what happens is the network thread just straight up exits um, after attempting this. So something bad happens in there. The heck? Oh yeah, there's a return in there. This used to be a different function, so return was the appropriate way of going away. Now, the only thing that we want to do is continue instead. Okay, that explains the problem. Test. Uh, uh, I'm gonna mute. That makes sense. So we dropped the packet and we started at sequence 2 and then we go up to 3, etc. Okay. If I drop 5 media packets like right away, I'm just gonna start a little bit more late and I'm gonna start at in like 6, etc. Well, we can do it. Test. Yeah. And that is fine. Let's do it in the middle. Blah 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 blah. Ah 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 ah. Now we are. Oh yeah. Oh yeah. Oh yeah. Blah 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 blah. Dropping audio packet, audio thread is too slow. So what's happening here is that we lost those 5 packets. They're never gonna come, but then we resume normally. So we play those 5 packets of silence, but now we're running ahead with this. Actually, is it? Are we really running ahead? I'm actually not sure why we end up running ahead. That is surprising to me. Audio thread is too slow. Why? Audio thread is too slow. When dropping packets from the microphone? Oh, no, wait. These are incoming media packets. Wait. We're dropping incoming media packets. Huh. Okay, I don't know. Blah, 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 blah. Well, but we are reasonably resilient to this. Okay, how do you enable forward error correction then? Turns out that what I thought was the way, it's not the way. Then there's also Dread. Let's take a look at Opus header files. Oh, there we go. Application VoIP. Optionally, it includes in-band forward error correction to protect against packet loss. Okay, the problem is that I was doing Opus Audio. Out, okay, so we should do application VoIP. And then, okay, let's try application VoIP. That explains a lot. So Opus application VoIP. Then we go in network, and we go in audio, and we set a bunch of false variables to true. Here we go. Okay, test. No, we still hear silence. Oh well. Do you need to do anything on the decoder side? Like, do you also have to tell the decoder how it works? No, frequency channels. You don't. Okay, so I set this Opus application VoIP. What else do you want, man? What else do you want from me? Um, what else do you want from me, man? This is useful when the caller knows that the speech optimized modes will be not needed. Use with caution. Encode this, encode that, sure, CTL, decoder, sampling rate channels, error, packet length decoded, max size, lost packets can be replaced with lost concealment by calling the decoder with a null pointer and a zero length for the missing packet. Dread decoder. Opus dread. Opus decoder init. Opus decode. Flag. To request that any in-band for error correction data be decoded. If no such data is available, the frame is decoded. Oh, if no such data is available, the frame is decoded as if it were lost. So that means so that's the pseudo silence that I was hearing. I don't know if you could hear it in the stream, but I was hearing a pseudo silence when the stuff was not working. So it means that the encoder needs to participate in this thing somehow, and I'm not doing it right. Dread decode flow. Let's see. Decode audio from an Opus Dread packet with floating point output. Decoder state. Dread state. Dread offset. Huh. Get this, get that. Checks whether the Opus packet has LBRR. What's an LBRR? Opus repacketizer, we don't really care about it. Get application request. Get set bitrate, max bandwidth, VBR, bandwidth complexity, in band. Oh, there we go. It's this one that we want. Zero, disable in-band FEC. In-band FEC enabled. If the packet loss rate is sufficiently high, Opus will automatically switch to Silk even at high rates to enable use of that FEC. In-band FEC enabled, but does not necessarily switch to Silk if we have music. Okay, so you would need to enable it elsewhere. But okay, at this point, I'm kind of less interested because the dread stuff, I believe that they say that the dread stuff is better than forward error correction. Dread duration request enables deep redundancy and use the specified maximum number of 10 millisecond redundant frames. Gets the encoders configure deep redundancy. Maximum number of frames, okay? 2, 4, 6. Set ignore extensions request. Dread duration, dread duration. Okay, so dread doesn't seem to be something you have to change much, it seems. Opus Dread decoder. Opus decoder. Opus Dread decoder. It contains the complete state of an Opus Dread decoder. It is position independent, can be fully copied. There's 109 references to Dread. In this document. Dread state of an Opus Dread packet. Okay. So there's a dread decoder. There's not a dread encoder, it seems. Opus dread decoder get size. Opus dread decoder create. Opus dread decoder init. Opus dread decoder destroy. CTL. Opus dread free. Parse, process, decode. Only called if Opus dread parse was called with defer processing. Opus decoder dread decode float, I guess. So you want an Opus decoder, a dread packet, decode Opus for an Opus dread packet. I'm confused as to this. This is the dread packet, I guess. I don't know what the dread offset is. Position of the redundancy to the code in samples before the beginning of the real audio data in the packet. How do I know about this? This seems like complicated / internal stuff. Okay, show me this. Show me Opus dread decoder. What do we have in here? Get size, create, because this creates an Opus dread decoder CTL. Oh no, please don't tell me that this is the last thing. So if this creates an Opus dread decoder, then where the fuck are we using an Opus dread decoder? Okay, show me all Opus mentions of Opus dread decoder. Opus dread decoder. Okay. Init. Okay, you call Opus dread parse, Opus dread process. This is really it? No, I don't believe it. Wait. This is it? Opus dread parse. And it gives you what? What's the output? Returns offset of the first decoded dread samples 0 if no dread is present. Oh. And then you do finish decoding a dread packet. Only needs to be called if output dread parse was called with deferred processing equals 1. So you just don't do this. The CPU intensive part of the dread decoding is deferred until Opus dread process is called. Okay. And then you call. Okay, so you need to have a normal Opus decoder. Then you need to have a Opus dread decoder. First, you pass the dread packet through the dread decoder, which will then give you the dread offset, and then you call Opus decoder dread decode on a normal decoder with the dread packet and the value that you got out of that function. And that will speed out samples, hopefully. Hopefully. Frame size must be a multiple of 2.5 milliseconds. Oh, but wait, this is what? I mean, the float one has the same restriction though. Thread offset position of redundancy to the code. Output signal interleaved with two channels. Length is frame size times channels. Yeah, frame size. Number of samples per channel to decode an PCM. Frame size must be a multiple of 2.5 milliseconds. Why? Why, man? So our dream of 20 millisecond packets is destroyed. So I guess we can change it to 25 milliseconds worth of packets, I guess. Or we can lower it. $17.5, 15. We could lower it to 15, but meh. Okay, I would be curious to try this Dread stuff out. Although this thing, I don't get it. Why does frame size need to be 2.5 milliseconds? I don't get it. Well, I don't know about this. I need to look into it more. So, yeah. Well, we did a little bit of work. So here's what I'm gonna do. I think I'm gonna stop here. We did stuff. Not a ton, but we did some. That's good. I'll look into these Opus Decoder Dread stuff a little bit more on my own. It has some curious restrictions that might make it basically just slightly more annoying to use than before. But what can you do? Also, I think that historically, like looking at the other documentation, Opus has always been better at documenting frame size. Like the documentation for normal stuff, for normal Opus stuff, is already imprecise. Who knows if this one is to be trusted or not? In any case, they do say that Dread is better than FEC, so who knows? Other than that, yeah, that's it. Yeah, I'm gonna do this some stuff offline on my own. Thank you all for hanging out. I hope you had a good time. And let me see if there's anybody that I should raid. Yeah, I think I'm gonna raid T2. Enjoy some European open source development, and yeah, enjoy and see you next time.